This is Mr. Hassan's Maths channel, and I'm now answering question number 7 from the May-June 2010 Cambridge Mechanics Paper 4. This is 9709 syllabus. This is Paper 4, Variant 3. It's an older paper, and this question is a little bit challenging. You've got to think a little bit about some parts of it, but it is still fine, no problem. It says two rectangular boxes A and B are of identical size. The boxes are at rest on a rough horizontal floor with A on top of B. Box A has a mass of 200 kilograms and box B has a mass of 250 kilograms. A horizontal force of magnitude P is applied to B. As we can see on the diagram, the boxes remain at rest if P is less than or equal to 3,150 newtons and starts to move. Okay, so the boxes start to move if P is greater than 3,150. Find the coefficient of friction between B and the floor. Okay, so what I'm going to do is just make a little diagram, although there's one there, just so that we got it down here. So we've got the floor. Oops, I'm trying to do a line here. So we got the floor, and we have the two boxes, which I'll just draw as one big block. Okay. You have box A and B. I'll just draw them separately, in fact. Okay, they're the identical size. That's box A and box B. Now, the total mass of these two boxes is going to be 450. This is 200 kilograms, the mass, and this is 250 kilograms. Okay, and you have a force, well, the weight of the whole thing. Okay, the weight of the whole thing is 450 G. That's going to be acting vertically downwards. Then you have the reaction force on B. The reaction force on B from the floor. Okay, this is reaction force on B by the floor. I'll put that. And you have this force P, which is pushing the boxes in this, like this. So I'm going to draw on this side, no problem. It's the same thing. So that's P in this direction. Now, what we have also now is, because you have a rough plane, you also have the friction between the box B and the floor. And because we're going to find the coefficient of friction, we know that F max, which I'll write down here, F max has to be 3,150, because you know that that's the maximum force that P can be, such that this will, be on the point of moving. If P exceeds 3,150, it will start moving. That means F max is 3,150 newtons. That is the maximum value of friction that can be generated in this situation, because the P force is acting horizontally. This is horizontal, so the frictional force here has to match that. That's a maximum value it can be. And we also know that F max is given by mu times R. And if we work out what R is, well, R, between the reaction force between block B and the floor, is equal to the weight acting downwards, which is 450 G. So R is equal to 450 times 10, which is 4,550 newtons. So we can say that F max, which is 3,150, is equal to mu times R, which is 4,500. So therefore we can say mu is going to be 3,150 divided by 4,500, and that gives us our answer. Where's my calculator gone? Oops, disappeared. So you have 3,150 divided by 4,500, which gives us 7 over 10, which is 0.7. So we got mu is equal to 0.7. Mu doesn't have any units. Okay, so there's the answer to part 1 of this question. Now for part 2. It says the coefficient of friction between the two boxes is 0.2. Given that P is greater than 3,150 and no sliding takes place between the boxes, show that the acceleration of the boxes is not greater than 2 meters per second squared. So basically what they're saying here, what this means here, is that the both boxes are moving. And no sliding takes place means that F max between the two boxes has not been achieved. Okay, because if F max has been achieved, then they're going to slide. Now let's just think about the situation first. You have a box and another box which are identical, and one is lying on top of the other. Okay, they're exactly the same size, right? And one is on top of the other. Okay, so you have these two boxes, box A and box B. Okay, so box A and box B. Box A, which is 200, is it 200? Yeah, 200 kilograms. And box B, which is 450 kilograms. Now, you have the reaction force between B on A. This is the reaction force of B on A. Okay, and you have the weight of A on B, which is 200 G newtons. Okay, now the force P is acting on B. Okay, the force P is acting on B. All right, and this force B is greater than 3,150 newtons. It's acting on B, not on A. Now, what's going to happen to A? Just imagine if there was no friction between A and B, and you pushed B along like this. A would just slide off. A would simply slide off. So in this situation, the movement of A is kind of like it wants to go this way. It wants to stay where it is. It doesn't want to move. It's going to stay where it is. It's just going to slide off. So as it wants to go this way, as it's tending to go that way, what's going to happen is, and it seems a bit counterintuitive here, but the frictional force is going to act in this direction. And we want to know the limiting situation. All right, the maximum acceleration cannot be greater than. So F max is achieved, but the friction is acting this way, because if you think about it, if you push this box that way, this thing is going to slide off, because this will move and this will stay as it is basically. So what's keeping these two stuck together is the frictional force, which must be acting in the opposite direction to which way this is going to try to move. Okay, in relation to B. In relation to B, it's going to move that way. So the F max this time is mu times R, and here the mu is equal to 0.2, and the R is equal to 200 G, which is 2,000 newtons. Okay, so basically we can say that it's accelerating, okay, with an acceleration. Okay, now you can say that the force that's trying to move it is going to be acting in this direction. Okay, although it's accelerating, the whole thing is accelerating in that direction. This is kind of the force that's trying to move it. So it's like the force that's trying to move it's going to be acting in that direction, and it's going to be the frictional forces that's going to be acting in the direction. So you could say that this is basically, you could say here is going to be like the mass times acceleration, which is 200 times A. Okay, that's like the resultant force on this object. Okay, and because it is in equilibrium, that's going to be equal to F max. Okay, so we can say 200 times A is equal to, F max. Now, what's F max going to be? F max is going to be mu times R, so it's going to be 0.2 times 2,000. Okay, that's F max is equal to mu R. So that's going to be 400 newtons. So this is going to be 400 F max. So therefore, A is going to be 400 over 200, which is 2 meters per second squared. So therefore, the maximum value of the acceleration is 2 meters per second squared. If it's greater than that, then this force that's kind of making it go this way, okay, which is the result of this moving that way, is going to be more than F max, and it will then slide. Okay, so it's a bit of a weird kind of question, and I'm sure a lot of students didn't really get this question too well, but it's something which you have to just think a little bit about, because just if you practically think about it, if you have a box on top of another box and you push this hard enough, the box on top will tend to want to stay where it is. And if there's friction, the friction is going to stop it from, moving. Okay, it's going to basically want to go that way. If there was no friction, it would go that way. So the frictional force acting in this direction, and the force that's kind of like you could say it's to do with the relative kind of movements of these two. This is going to move in this direction. This is going to try and stay the same. So you can say like the force acting on between these surfaces. There's a force acting in that direction, which is caused by this moving that way. This is moving that way. That's going to want to stay the same. So if we think about it, it's like there's a force acting in this direction, and the frictional force is stopping it from moving, and therefore that force, which is ma, is equal to F max for it not to move. Okay, they have to be balanced out for it not to move. And if the acceleration became more than 2, then ma would become more than 400, and then it will start sliding. Okay, so that's the best way I can really explain this question. It's a bit of a weird one, but I hope that was clear enough for you to understand. Okay, now once we've got that, and once we know that, the rest is quite easy. Saying find the maximum possible value of P, okay, such that basically no sliding takes place. That's what they mean. All right, so what we're going to do now is we're going to simply just take the situation as if they were one object. Okay, again, back to what we did before. And this time we know that the weight of the whole thing is 4,500 newtons, and the reaction force is equal to that. And you got the force P pushing this way, you got the F max in this direction. So you got P and you got F max. Okay, so we know already F max is equal to 3,150. We already know that. Okay, that's between the floor and B. That's F max. We know that already. Okay, so we can resolve the forces on this. You can say P minus F max equals the mass times the acceleration. So we can say P minus 3,150 is equal to the mass, which was 450, times the acceleration, that's the maximum acceleration such that it doesn't move. So you're going to have P equals 900 plus 3,150. So that's going to be 4,050, right? Let me just make sure of that. So you have 900 plus 3,150, 4,050 newtons. So the value of P is 4,050. Okay, so that is the answer to that question. So we can say P is equal to 4,050. We don't have to put newtons because it's already defined as being P newtons here. Okay, is it? Yeah, P newtons. All right, so we end up with P equals 4,050. Now that's because now we want to find the maximum value of P, which will that means without those two sliding, without any sliding taking place. So basically, that's when the acceleration is equal to 2. That's the limit, as we said, 2 meters per second squared. As long as the acceleration is limited to that, that's a maximum acceleration for sliding not to take place. So we're looking at the maximum kind of case here, where the resultant force is equal to the mass times acceleration. We're looking now at the forces acting on B. Okay, because that's how we can deal with this, because P is acting on B, and so we have to consider the forces acting on B. So we already know that the F max, we already worked that out in the first part of the question, is 3,150. Okay, and that was because that was the maximum value of the friction that could take place. Okay, so that is the answer to that question. I hope that was clear. Other questions from this particular paper, if I ever am asked any questions from this paper, will be in the playlist that will appear in this area over here. Other questions from this topic, which is to do with, I guess, dynamics. I'll put something here for dynamics and forces and friction. Okay, another playlist for friction. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.